Here we go, everybody. All right, we learned this special phrase right here. And that was, um, giving some sort of like longer, complicated phrase to explain a really simple concept. Okay, when you have two countable objects, we call them quantities, that relate in a special way and that have relate as equivalent ratios all the time, then we have what's called a proportional relationship. So if you kept, right, we had, I think one of our groups, one of my classes, talked about a ratio of circles to stars as 3 to 4. Okay, well, a similar relationship between stars and circles and stars would be 6 to 8. All right, so this is proportional. The number of circles is proportional to the number of stars because we can see that we have a group of 3 and a group of 4 here. Okay, but when we have 6 and 8, okay, there's a group of 3, and that goes with this group of 4, group of 3, group of 4. Okay, so that shows us that they're still in that, they're equivalent ratios because for every 3 circles, there's 4 stars. Okay, so we can see how that works, and we can change that into kind of fraction form. If we look at this, and we know that that's going to equal 6 to 8. Okay, we can write ratios as fractions, and we can see that, right, whatever we multiply the top by, we can multiply the bottom by. All right, and we get an equivalent ratio. So you've worked with them both ways. When you were younger, you looked at ratios this way. And as you got older, you started to look at equivalent ratios like this, like fractions, okay? So equivalent fractions, you have to multiply the top and bottom by the same amount. Now, there's some other ways to test if fractions are equivalent, and we'll go over those. But our job is to now just determine if a relationship between two amounts or two quantities is going to be equivalent and therefore proportional. So when two quantities or countable amounts or measurable amounts, right? Quantities have we call it constant if it's always the same, constant ratio. All right. So for instance, when we first compare the numbers, it was 3, 4. And when we compare another pair of those numbers, it was 6 to 8. Since those are the same ratio, this would be called a proportional relationship between circles and stars. All right, so let's look at some other ones and let's test to see if we have proportional relationships. So copy this down into your notes. You can always pause or rewind if you're not getting something, and then ask when I return so that we can make sure everybody gets it. All right, so here we have a recipe for homemade glass cleaner, and it looks like the recipe is that you're going to put together a ratio of 1 part vinegar to 4 parts water. Okay, Elise, when she goes to, looks like she needs more of it, so she mixes 3 tablespoons of vinegar to 12 tablespoons of water. Now, what are we trying to determine? Let's look at the bold print here. Is the relationship between the vinegar and water in the recipe and the vinegar and the vinegar and water in the recipe and the vinegar and water in Elise's cleaning solution, is it a proportional relationship? So what does that mean? Well, oops, if we look back out here, what is proportional? It's when the two quantities have a constant ratio. So we're just going to test these two ratios. We can do it in a bunch of different ways. Let's just write two fractions. Okay, so we have 1 to 4, and I'm just going to off to the side remind myself what the 1 represents, which quantity it is. So that's the vinegar, just abbreviate real quick, and this is referring to the water. Okay, and when I write my other ratio, I have to make sure it's in the same order. So I've put vinegar on top, I got to put vinegar on top on my other one because they have to match up to check the ratios. Okay, so it says right here, it says 3, and we have to 12. Okay. And that's vinegar to water. Again, it's in the same order, top and bottom. All right. Now we just check if those are equivalent. There's a couple ways you can do it. We can say, well, that times 3 is 3. and then check, is this the same multiplier times 3? Yay. All right. 4 times 3 is 12. So these are equivalent ratios. All right. So we had to say, is the relationship proportional? So yes, it's proportional, and explain. Okay. So yes, it's proportional because the ratios are equivalent. All right, write all that down. Hopefully that makes sense, right? And if there might be some problems where we have to come up with some different strategies to test these ratios, besides just noticing that there's a common multiplier there. All right, but we'll continue to look and see if we can figure out, okay, what that is. All right, so let's look at this second example. Pause it, try it yourself, and then check with my work, okay? No, seriously, pause it. Did you pause it? All right. So after you've done all the work, now I will show you how to do it. Refer to the recipe for homemade glass cleaner and mark in example 1. Okay, so what was that ratio? That was 1 to 4, vinegar to water. All right, and then Marcus mixes 1.5 cups of vinegar, 1.5 cups of vinegar, and 6 cups of water. Okay, well, are these equal is what we're asking, I guess. Well, let's just make sure. Is the relationship between this blah, 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 proportional relationship explained? Okay, well, we have to see if they're the same. Are they the same? Well, this is a little bit difficult. What's the relationship between 1 and 1.5? It's a little tricky. Okay, well, so we can also check to see if this and this relationship are the same. Okay, so we know that this is times 4. So we could check here and see if that's times 4. Let's see if we put 4 times 1.5. I guess I could do it this way too. All right. Let's see. 4, 1.5 would be 0. We carry the 2, right? 5 times 4 is 20. And 4 times 1 is 4 plus there's 6. There's 1 decimal place, so we'll put that there. So yeah, so looks like that's times 4 as well. All right. Now we could test it another way. Write this way down. Okay, this is called cross products. All right, we can just multiply that, and if they come to the same number, then these ratios are equivalent. So this is called checking the cross products. If the cross products are equal, then the ratios are equal. So we know that 1 times 6 equals 6. And we check this cross product, that's 4 times 1.5. And we already did that math right over here. We know that equals 6. So since it's 6 and 6, we know that these ratios are equivalent or equal. Okay? So we can say, yes, the relationship, yes, it is proportional because the ratios are equivalent. All right. So 2 for 2. We had equivalent ratios, so we call it a proportional relationship. Now this is a proportional relationship between vinegar and water. Those are the two measurable things that we're comparing. And whenever you're doing a recipe, right, you want those ratios to be the same, or else you're going to get something that tastes a little bit strange or different, or doesn't really match what you remember from Mama's favorite, your mother's famous chocolate chip cookie recipe. All right, still scrolling today. All right, we got another one. Let's check it out. We got a 5-mile taxi ride in one city costs Anaya $25. A 4-mile taxi ride in a different city costs $18. Assume the cost in each city is the same amount per mile. Ooh. Okay, assume the cost in each city is the same. Oh, look, to give us a clue. Now, this is from last lesson, right? This kind of tells us how to set up our division. All right. Is the relationship between the number of miles and the total cost between the two cities a proportional relationship? Okay, so let's check it out. We are going to set this up and see how it says amount per mile. Okay, so we can write that as when we write our two ratios to check if they're equal, we're wondering if it's equal, we can say amount per, right, is that division bar right there, or fraction bar, but we're learning that it means division as well, per mile. Okay, so we're just going to fill it in. Let's fill in Anaya's first. She can go, amount goes on top, so that's $25. And she goes 5 miles. And then we have a different city where it's 18 and 4 miles. Are these equivalent ratios? Okay, well, here's another way to test. If it's simply, right, we can test, and this might be the most useful way, is thinking of this as division and this as division and just dividing the two numbers. So another way to test if ratios are equal is just to divide the top by the bottom. All right, so, right, 25 divided by 5 is 5. 18 divided by 4. Now, I don't need the specific answer. I already know that 18 divided by 4 does not equal 5. Okay, I happen to know that it's 4.5. Okay, you could do the long division to test it. All right, top dog gets the doghouse. See, I say this is like the doghouse, and this is the top dog because it's top of the fraction. Okay, top dog gets the doghouse. 4 doesn't go into 1. 4 goes into 18 4 times. 4 times 4 is 16. Minus, subtract 2. Bring down a decimal. Bring it up there too. 4 goes into 20 5 times. Okay, so we get 4.5, and they're not equal. So what are we going to say? No, it is not proportional because, yep, you thought it, because the ratios are not equivalent. All right. You're probably getting the hang of it. We have 3 different ways to test, right? So make sure you use these notes as for different problems. If you have issues, okay, right? We had multiplication this way. Okay, we had cross products. All right. And up here, we just saw, you know, the ratios that we practiced yesterday. So there's different ways to check if ratios are equivalent. I think this way is going to be one of your most effective ways and most useful ways, especially as we get into deeper into proportional relationships. Just divide the two numbers, see if they come to the same answer. Okay? All right, last one for now. Let's go. One type of yarn costs $4 for 100 yards. Another type costs $5 for 150 yards. Is the relationship between the number of yards and the cost a proportional relationship between the two types of yarn? Explain. Okay. So how much yarn could you get? Let's check that. Set up our proportions. Now, it doesn't really give us a clue as to how to set it up. All right. But let's see if we can figure something out. All right. So usually money goes on top. So we go dollars and yards down here. Okay. So then we can figure out how much money it is for 1 yard. Or you could figure out, I guess, how much yards you can get for $1, but not typically as useful, but if there, I could see a use for it. Okay, so you can set it up like that, or if you flip them both, like I said, yards, just make sure whichever way you choose to do it, you set them up with the corresponding numbers in the right spot. So this would be 100, oops, sorry, 150 over 5, and then 100 over 4. This looks like could be just one of those division problems, right? But we could also do cross products. It doesn't look like we can figure out a nice multiplier there, so that's not going to help us very much. Let's just divide. How about we do that? It looks like 150 divided by 5 is a simple problem, 30. So 150 divided by 5. Okay, if you have to do the long division, right? Just Plot it over here. Make sure, no, 5 goes into 15 3 times. 3 times 5 is 15. Minus, oops, we get 0. We bring it in. 5 goes into 0. 0 times. Multiply, subtract. Okay. And then 4 times what is 100, or 100 divided by 4? And hopefully you know what a quarter of 100 is. That would be 25. Oh, those are not equal. These are not equal ratios. So we can say not proportional. Let's abbreviate so we don't have to write as much. Not proportional, not equivalent ratios. Okay. So now we have a couple examples of equivalent ratios, a couple examples of non-equivalent ratios. Pause if you need to, or go back. Okay, we're gonna save this for another time. That's all we need to do right now. All right, and hopefully you have a good understanding of how to check if two quantities are in a proportional relationship. Go back and look over it again if you don't get it, and now let's do some practice.